Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 to 95. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport runway 14 for an ILS localizer landing. So now in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787 900Z aircraft. I'm gonna start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute, all the sleep so that trigonometric angles and decrease can climb and descend. We have also the ILS localizer that receives the onboard antennas of the ILS localizer of the aircraft that receive the radio frequency transmitted from the threshold runways of each runway we use for takeoff and for landing. We have the antennas that transmit the radio signal of the ILS localizer, the horizontal localizer, and the vertical glide slope for approach, for horizontal alignment, and also for the angle of approach. So we have a unique radio signal frequency we can tune from the ILS localizer on board the aircraft using the flight management computer or the navigation radio. So you will see how we're gonna use that. And we have to be aligned with the magnetic north pole heading of 136 degrees for the runway. We have the runway 14 in Zurich International Airport, Lszh in Switzerland. So we have to be aligned with the runway heading, magnetic north pole heading. You will see later when we're going to be flying the ILS localizer displayed over here in the primary flight display. So also we have the angle of attack we have other indications. Also we have the ILS localizer crossbars, we have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode annunciator with the autopilot and the auto throttle, lateral vertical navigation modes. We have also the HSI that displays the horizontal situation indicator, the magnetic heading and track, and also the integrated display of the flight plan. So we're gonna create a flight plan or a flight path or a route using the flight management computer. Over here you can see the flight management computer, so I will show you its parts and its functions, the modes we can use, also interconnected with the autopilot and flight director system panel. Over here we have some modes from the flight management computer so we can follow the flight plan. You will see later the magenta or purple lines over here in the navigation display, also in the HSI of the flight plan we're gonna create. So it's gonna be waypoint by waypoint navigation. The waypoints are horizontal vertical navigation features. Now the airspeed constraints, we have to fly through some waypoints when we select from the flight management computer when we create the flight plan of the aircraft. So you will see how we're gonna create the flight plan. Also you will see the navigation display. What it displays, we have the horizontal and the vertical profile of the aircraft as it flies. You can see the horizontal and vertical profile of the terrain around you, also the weather radar. We have the terrain and weather reflections from the weather radar. You can see the red, green and yellow and other indications of the terrain and also the weather. So you can see the terrain elevation depending of the distance you select in the navigation display, displayed with red, green and yellow or amber. And we can see also with blue the sea, the lakes and the rivers. We can see also the inertial reference position of the aircraft, the longitude and the latitude from the flight management computer. So we have the GPS position of the aircraft and we need to make an alignment. You will see later how we align the aircraft using the inertial reference system, their data computers and the GPS receivers. So you will see we have the magnetic north pole and the geographic north pole and magnetic variation depending on where we are in the world. We have also in the terrain map you can see the airports displayed with the 4-letter ICAO name with a blue color. Over here you can see our own airport. Over here the Zurich International, and where is the aircraft, you can see a few airports further away, like here is Germany, over here France on this side, here is Switzerland down here. So you can see further away, further distance over here, more airports clutter. You can see also the waypoints. So we have also the airports that can display the taxiways we use for taxiing into the runway for takeoff and for landing. Also the runways, you can see the runways, the length, the direction of the runway, the magnetic or geographic direction in degrees, and also other data. So we have also the navigation aids, the nav aids, which are the voice stations, the ADFs and the ADPs. We can tune the frequency and navigate the aircraft. We have also the waypoints, as I told you, which are horizontal, vertical navigation fixes and altitude and airspeed constraints. We're gonna be having to fly through some waypoints during every flight because we create a flight plan that contains waypoints, and it's connected waypoint by waypoint with a magenta or purple line. You can see both in horizontal and vertical profile. Also in the navigation display, we have the display of other aircraft that fly around our own aircraft using the transporter, the DSP and ADC transmitter receiver that transmits a radio frequency to other aircraft, and the air traffic control and receives from other aircraft can calculate from its computer where the other aircraft are positioned, the distance from our aircraft and position, also the altitude difference from our aircraft, how many hundreds or thousands of feet are above or below, whether they climb or descend with respect to our aircraft, and also you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning if we have an incoming collision with another aircraft in the air from the TICA system, the traffic collision advisory system, and also in the ground you can watch for other traffic in the taxiway and the runway. So we have also the navigation display. We have I will show you also the flight controls of the aircraft, how to use the flight controls. Over here are the systems for the pilot flight director system panel, the engines indications over here, the thrust levers. Also you can use the thrust levers to increase or decrease the thrust, and the engines are commanded from the FAREX over here. So you can see the engines indication, increase and decrease, takeoff thrust, idle position. So we have the FAREX. The FAREX are the full authority. These electronic control computers, one installed current gearbox, dual channel redundancy, one channel phase, the other takes over, controls, monitors and displays all the NG data, including the upper and lower ACAS and presentation control the system display, malfunction display, like the N1, loudspeaker and ground. The N1, which is the low speed starters, low pressure compressor, turbine of the turbo 100% engine, the exhaust gas temperature parenting. The N2, which is the high speed starters, high pressure compressor and turbine of the turbo 100% engine. The fuel flow parameters per 1000 kilograms, 1000 pounds of pressure, temperature, quantity, and the vibration of the N2 states of the engine. So you can see also the data of the engines, the primary flight display. I will show you now. Also, so you can see the engines, what they indicate over here. So we have the N1, which is low speed starter and sub low pressure compressor turbine of the turbo fan puts engine, the left and the right. The exhaust gas temperature per engine over here, and one exhaust gas temperature, and two, which is the high speed starter, high pressure compressor and turbine of the turbo fan engine. The takeoff maximum thrust 99.2 with green, and also red never exceed, amber it's a warning. Also we have the exhaust gas temperature in 2, fuel flow parameter per hour right now is thousands of pounds, oil pressure, it can be also kilograms, oil temperature, oil quantity and the vibration of the N2 states of the engine, the gross weight for takeoff over here you can see 358,700, total fuel on board 35,900, cabin altitude for climb over here, rate of climb. Also the engine's pressurizer supplies from the 5th and 9th stage of the engines, and from the bleeder, from the bypasser it can supply. In the Boeing 787 we have an outside compressor for that. It supplies the cabin pressurization over here of the aircraft. So you can see when we fly we pressurize or depressurize the cabin, climbing or descending. So we have differential rate, it can go 7.8 psi maximum pressurization when we are at 43,000 feet, and cabin altitude 8,000 feet, landing altitude also and the outflow valves position over the climb. Other things we can see: flaps, stabilizer trim, rudder trim over here. The landing gear now is extended, is down over here, so you can see landing gear down. Alternate gear, auto brakes over here. So we have the cabin pressurization. We can set from here in the overhead panel. The outflow valves in the auto or manual. We use the outflow valves. You'll see in a couple of seconds. So I will show you now the flight controls and the primary flight display. You can see how I'm using the side stick. I can control for climb descent, also make left and right turns. The most important part, one of the most important part of the aircraft flight control system. So you can make left and right turns. You have directional control in the air, also in the ground, rudder pedals, and you can use the nose wheel steering, the forward nose of the aircraft nose wheel. So we climb with descent. We use the elevator for climb descent. The elevator moves up, we climb. The elevator moves down, we descend. Also we have it pitches down the nose, pitches up the nose. We have the control wheel for the aileron, spoilers and flaperons over here, as you can see, and the rudder pedals control the nose wheel and also the vertical rudder. So I will show you now. You can see I have the side stick from the Airbus over here to control the aircraft. Also my computer set up over here. The keyboard, I control the computer, and the mousepad I can use the mousepad also to control the flight management computer. You will see in a couple of minutes. So I have the mousepad mostly for this and for the autopilot flight director system panel. It's in the switches, also in the overhead panel. So you will see now from the flight controls. I need to explain you. I will show you the outside view of the aircraft, and I will explain the aerodynamics of the aircraft when it's flying for the air transport pilot license and the commercial pilot license. We need to know the Newton's physics, aeronautical and aerospace engineering, and aerodynamics. So we will have to know some intuitions and some principles. So I will show you now the outside view, and show you also the flight controls alongside, how to control the flight controls, how to use the aerodynamics, the rudder pedals over here for the vertical stabilizer, and also for the nose wheel control in the ground. So you see the outside view of the aircraft. You can see the forward wings hold the weight of the aircraft when the aircraft flies. We divide the aircraft weight over the surface area of the wings. That creates the lift force, lift the aircraft in the air. Using the propulsion, we have the thrust vectors from the engines, the jet blast from the jet engines that move the aircraft forward. So you can see we have the exhaust cone over here, the jet blast from the exhaust cone behind, and also from the bypass air. Also we have the high pressure compressor and turbine back here, and the low pressure compressor and turbine in the front side with the fans, and also the combustion chamber. This is the main parts, the fuel flow over here from the engines, from the fuel tanks over here. So we have the fuel lines also, and perhaps the engine got the eyes over here, the wing and engine got the eyes. So we have the left and the right wing fuel tank inside the wings, also the center tank over here. So we have the center of gravity over here. So we have the main aerodynamic cord over here. Is the mark where is the maximum aerodynamic lift occurs in the forward wings. Also is where the center of pressure is moving back and forth in the top surface of the wings when we fly. Also the stall begins, the airflow becomes detach from the top surface of the wings, and the aircraft goes into stall for a given angle of attack and airspeed in flight. So you need to monitor over here from the primary flight display. Over here you need to monitor the airspeed is correct, is above your stall speed over here all the time. So you will see the stall speed with a number and red indication down here. Red number indication. So you need to apply more thrust and push the side stick or the yoke down to decrease the angle of attack of the aircraft and increase your airspeed to avoid the stall. So this is the stall avoidance. We have also the minor dynamic or where the maximum dynamic lift is also where the center of gravity is located because of the fuel tanks here, the center, the left and right wing. So we have 30% in the left and the right wing right now and 10% in the center fuel tank. So down here with the vertical axis is transverses the yawing axis over here, the yaw of the aircraft, so you can make left and right turns using the rudder pedals. The rudder you can see over here. So this is down from the center of gravity. The rudder control. We use the rudder pedals over here, as you can see, for the rudder control, only rudder pedals. And I have in the size left and right vertical. So we control the rudder pedals like this. Also we have the control of the tiller, the nozzle steering. Many aircraft you have interconnected. So from 0 knots also you control alongside with the rudder. From 0 airspeed up to 45 knots you have a deflection of 76 degrees either left and right, the forward nozzle to make left and right turns using the forward nozzle steering over here from the rudder pedals again, or the nozzle steering from 0 to 45 knots. Above 45 knots you have the rudder is becoming aerodynamically effective over here. So you take control above 45 knots, more with the rudder, less with that. You have it decreases above 45 knots from 76 degrees deflection either left and right to 7.6 degrees only. So when you increase your airspeed to 80 nautical miles or 144 knots in takeoff or in landing, you do the inverse, you decrease. So it deactivates above 80 knots, reactivates below. So you have only the rudder above 80 nautical miles per hour in takeoff, like 144 kilometers an hour, for directional control using the rudder pedals. So also you have, you can see nozzle steering and the tiller for, you have also the toe brakes in the rudder pedals. Also we have another axis here, is from wingtip to wingtip. Over here is the lateral axis. It's the axis we control and the side stick in the Airbus for climb and descent like this. You can make climbs and you can make descents of the aircraft using the elevator, and also the elevator pitch trim switch. You can trim the aircraft elevator to balance the aircraft in flight. So this is the pitch trim and the elevator control, the pitch attitude in flight, pitch up and pitch down, the side stick up and down in the Airbus, back and forth. Is the yoke back and forth in the Boeing for controlling the tail like this. So you see the yoke in the Boeing up and down. It's in the Boeing aircraft, both sides are interconnected, move together simultaneously, rudder pedals, control wheel. Not like in the Airbus you have side stick priority, in the Boeing to move together. So you control, you may climb and descend the elevator like this. And also we have We have one more axis, is the longitudinal axis from the nose to the tail of the aircraft over here. The transverses all other axes. You can make rolling turns. It's the side stick left and right in the Airbus, and it's the control wheel left and right in the Boeing. So it's the same flight controls that you control in all aircraft. You see left and right side stick in the Airbus, ailerons and spoilers left and right. So this kind of control. So it's side stick left and right, the rolling axis, the longitudinal axis of the aircraft, make bang rolls in flight left and right. You can use all flight controls together. So you make bang rolls with the control wheel. Like this is the side stick in the Airbus, is the control wheel on the Boeing to make left and right turns. So the elevator, climb, descent. You can move together all flight controls, like in the real aircraft, and the other pedals. So you have coordinated turns, climb, descent. So this is a coordinated turn like this, or climbing turn. Climb, descent. So we have also finishing the aerodynamics now, the top surface. We have the bottom surface of the wings, you can see is more flat, and we have the flaps extended. So when we accelerate for takeoff about 140 nautical miles per hour, the airflow is moving slower below the wings using the Bernoulli stereo fluid. So we have higher air pressure, which pressurizes the aircraft weight and wings up into the air, like 250 kilometers an hour in takeoff, and then in flying using the thrust from the engines. Also the top surface of the wings, you can see it's more curved, so we have higher airspeed above the wings, the airflow moving much faster using the Bernoulli theory of fluids. So we have lower air pressure, which sucks the aircraft weight and wings up into the air. So this creates the aerodynamic difference between differential pressure, higher pressure below the wings and lower pressure above, and the aerodynamic lift of the aircraft. So I'm gonna show you now a little bit more of the flight controls over here. I'm gonna show you also the displays. So you see both sides moving together, captain and first officer are interconnected. Also the side stick deflection is proportional to the yoke deflection, like this, as you can see. So it's quite fast, you can leave neutral also, and the rudder pedals. So I'm gonna show you one more view of the flight controls of the Boeing 787, then I will proceed. I will show you also the horizontal trim stabilizer, how to use the trim of the aircraft, also the displays, the primary flight display that I left behind, so, and the navigation display. So you will see how to control the aircraft using the flight controls. You will see one more nice view, the thrust levers, also the engines control, and the horizontal trim stabilizer, the flaps and the slots, and the speed brakes, which are secondary flight controls. So we need to pay attention to every system before going into flight. So you will see again the side stick that I'm using, my computer over here. You can see it's the Airbus side stick. You can see one more view of the aircraft flight controls over here. So you can see we can climb and we can descend again. We can make turns left and right. like this. We have full flight controls. Hope you like this view also. The engines here. You can use the engines thrust. Over here increase and decrease, as you can see. We have this slider over here. So we can control the engine thrust propulsion, as you can see, very easily as we fly. So we use all flight controls together. So we can climb, we can descend, we can make turns to the left and turns to the right. So we increase and decrease the thrust here, the propulsion from the engines. So this is all the flight controls. As you can see, also the outside view. So we can climb and we can descend, make turns using the rudder, vertical stabilizer. So this is side stick deflection, yoke in the Boeing, rudder pedals, directional steering and nose wheel, and irons and spoilers like these, left and right iron spoilers. So I hope you like the jet aircraft that I'm flying tonight, the Boeing 787. Stay until the end part to see the whole flight. After finishing all the systems functions we need to know. So I believe this is enough for the flight controls tonight. This is side deflection proportional to the yoke, both captain and first officer moving together. In flight they're interconnected. They're not like in the Airbus you have the side stick priority for either side. You can only override by force, only like if you have a failure in flight in the Boeing. So this is the system, the flight controls. Hope you like. So now we go with the rest of the systems. We'll show you the display also, primary flight display and horizontal trim stabilizer. We need to know for the horizontal trim stabilizer how to trim the aircraft up and down, because it's part of the flight controls. Then we'll see the primary flight display, what it displays. So maybe we'll see first the primary flight display over here. So you can see here we have the primary flight display. You can see we have the airspeed indicator here, the airspeed tape, the airspeed selected from the autopilot flight director system panel, The ground speed is displayed here in the navigation display. The radio altitude above the ground level, you can display up to 2,500 feet over here when flying above the ground also. So this airspeed, radio altitude and barometric altitude above the sea level, target airspeed and target altitude from the autopilot flight director system panel, flight mode annunciator here, and the pitch ladder and the bank roll in decrease, the wings level of the aircraft here, the symbol, the altitude indicator with the artificial horizon, and the sky in the top. So you have here the magnetic heading here selected from the autopilot flight director system panel. So a better look over here of the displays. You can see barometric altitude 1430 feet, the vertical rate of climb descent of the aircraft, vertical speed indicator. The displays have fuzzy climb descent like 500, 1000, 1500 over here, 2000, 3000, 6000 feet per minute climb descent. You see the needle moving up when climb, when moving down when we descend. The pitch ladder, it decreases over here like 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20 for pitch up and pitch down. Also you have to pay attention both to the airspeed and the vertical speed when flying, and the pitch altitude. Also the bank turns over here, so you can see like 5, 10, 20, 30, 45 degrees left and right bank rolls. When you turn, flight mode annunciator, takeoff, ground mode. So you're gonna see it a little bit different when we set up the flight management computer. So you can see here we have 200 nautical miles per hour from the autopilot flight director system panel, 360 degrees heading, 10,000 feet. The selected altitude, vertical speed right now is not selected, displays blank indication. So we have autopilot engage and disengage, auto throttle left and right, LNAV and VNAV, lateral navigation, vertical navigation, flight level change, climb continuous, auto throttle, flight director on and off, very important, bang heading and also bang roll and heading, vertical speed, flight path angle, and also the altitude, hold word localizer, and approach throttle. And so you see the airspeed in nautical miles per hour or max speed is 200 knots right now over here. As you can see, indicated airspeed, heading, and altitude is the same values as displayed in both sides of the primary flight display, 200 knots and 10,000 feet. You can see both sides, this left and right side, captain and first officer over here. You see again 200 knots and 10,000 feet, selected values with the flight director for the autopilot, VR, and magnetic north-south heading, ADF left and right. So we have barometric pressure over here for the barometric altitude, 29.92 inches of mercury, and the radio minimums, landing altitude over here. So we set the barometric pressure altitude over here. We'll show you after the aircraft is approaching for landing over here, as you can see. So we see an L737 800s has landed. So I'm telling you about the primary flight display. The airspeed indications is from the pitot dynamic, and the altitude and vertical rate of climb speed is from the pitot static and pitot dynamic also. Pitot static mainly. So we have the barometric altitude setting 29.92 inches of mercury, and we set here from the baro set 29.92 inches of mercury or hectopascals, as you can see over here. You can set the barometric altitude, right now is 39.92 inches of mercury. You can set 1013 hectopascals, range, the plan, the map, the menu, minimus radio, weather radar, traffic and terrain on the display, accept, cancel, reject some warnings over here. So you can see the displays here, what it displays from the plan. The range over here is 80 nautical miles. Over here you will see the ground speed, the wind direction speed, the maps. Over here also the aircraft symbol, how far above the ground we will be flying, the terrain, the distance, and the altitude. So you will see the terrain below you when flying. Over here in the navigation display, also the flight run. So we have set barometric altitude over here 29.92 inches of mercury, or 1013 hectopascals. Right now we can set different. You will see all displays the same. So you see this barometric altitude right now 29.92 inches of mercury in this barometric altitude. So all the air data you see here, the pitot airspeed, pitot altitude, pitot fluids, dynamic, and also static, and also the altitude indicators, radio altitude above the ground level displays like 2,500 feet when flying, the radio altimeter, and also magnetic north pole. All air data are displayed and controlled from the air data computer here, the inertial reference system. So you can align also your GPS longitude and latitude, and magnetic north pole, geographic north pole, airspeed, altitude, pitot tubes, laser gyroscopes for alignment of the aircraft, and the altitude precession. So these instruments work with laser gyroscopes over here for precision and deceleration. So you will see later what we can do with that. So we have a couple more things to see. We have also the displays indication here, some systems, system display, CDU, info, checklist, communication, navigation display, ACAS, engine console, left and right, extend the map like in the right side, or have the engines or other systems like you will see later, the electrical over here, hydraulic, fuel tanks, pressurization are going to be displayed over here in the systems display. So we have a couple more minutes. I will show you now the horizontal trim, stabilizer control, and some secondary flight controls, and then we're gonna make the flight plan for flying the aircraft. So very fast, you can see we have the elevator over here, the side stick, move up and down the elevator for climb and descent, or the yoke. So we can also trim the elevator surface when flying. So trimming helps the aircraft flying more precisely, less work for the pilot, aerodynamic effects in the control system. So you can see we have one switch here in the control wheel. It's the horizontal trim elevator. Some other aircraft is the whole stabilizer control. So this way you can see elevator trim over here. So you see elevator trim over here, left click down, right click up. So you see elevator trim, left click down, right click up. So you trim the elevator up and you trim the elevator down. You pitch the nose of the aircraft as you fly. You have this aerodynamic effect. Pitch the nose up, you pitch the nose down. So you trim the elevator up, you trim the elevator down. You can see clearly the tag, what it displays. Elevator trim, left click down, right click up, and you see the movement. So this is the normal flight control computer's channel for controlling this function. You can see also the flaps position. Here we have the head-up declarer switch, and the autopilot over here, disengage switch. So we have 2 more switches, so mainly this. And you see the effect, horizontal trim, stabilizer. Over here you trim the elevator when flying. So you balance the aircraft using the elevator trim in flight. So you have the flight control computers over here in the normal, in the auto position. Primary flight control computers control all the flight controls of the aircraft, like in the Airbus. aircraft in the Boeing 787 and 777. You have load limits Z turns, like in the Airbus you have 2.8 Z's in left and right turns, so 67 degrees maximum limit allowed. Also in the climb you have in the Airbus 30 degrees and 1.5 G in climb, and minus 15 degrees or minus half G in descent. And other also limits and protections. So you have the flight control computers. When you fly, they give you when you move the flight controls over here, you give an order in the flight control computers. So you have the normal, the alternate and direct flow, like in the Airbus aircraft. So you have here the alternate flight control computer for the horizontal trim stabilizer, and the auto trim here. Disconnect. So you have the horizontal trim stabilizer over here again. You trim this way the nose up, and this way the nose down again. So you trim the elevator. You pitch the nose up as you fly, you pitch the nose down. So this is instead of a trim, we have this switch over here, nose down and nose up. So you see again elevator, trim up and trim down. We have also the parking brakes here set. We have navigation radio here, VHF, HF, SAT, high frequency, very high frequency cabin, ground proximity, weather radar, transporter. So you can see the transporter of the aircraft over here. The fire extinguishers for the left and the right end, we pull out and switch. Also the radar trim over here. So this is radio communication management panel, navigation radios. You have the fuel control for the left and the right engine, you will see later. Auto throttle disconnect switch, the thrust levers. You press this switch, you disconnect the auto throttle, takeoff, go around, thrust reverse. So this is the thrust levers control, and also the auto trim stabilizer. Disconnect the switch left and right if you have a failure of the flight control computers over here that affect either channel. So you see the hydraulic fluid over here, hydraulic pumps, left and right engine driven, primary demand, and electric. So you have a failure that affects the flight control computers control. You will lose the auto trim function because you have an automatic trim. This is a fly-by-wire aircraft. You can trim its own self by the flight control computer. So you will lose the auto trim if you have a failure that affects either the left and right horizontal trim stabilizer over here. So this is for all Boeing 737, 747, 757, 767, and Boeing 777, and also Boeing 787 aircraft. You open from normal to cut off this switch, then you disconnect, and you have only the alternate and the manual trim switch over here. So you also have the manual trim for the horizontal tail. You can see the position, how many degrees you trim the horizontal tail over here. So you see nose up and nose down, stabilizer trim over here, very nice 5 degrees, rudder trim, also flaps position. So we need to set the flight management computer very quickly. You see I'm having here the computer, I'm having the side stick, I also have the mousepad to control, and the keyboard to control the flight management computer, to enter the flight plan of the aircraft and the takeoff gross weight. So we're going to use the takeoff gross weight and other data of the aircraft for this flight. That includes the integrated plus passenger plus cargo plus fuel on board. Where the fuel is on, we have 30% left and right wings, 10% in the center tank. The flight management computer is going to calculate the center of gravity from takeoff, climb, cruises, and approach and landing. During the whole flight we burn fuel, so the center of gravity is shifted. So the flight management computer is recalculating every second. It gives us the mean aerodynamic chord position for takeoff. Also the horizontal trim stabilizer for takeoff. We're going to use 15 degrees of flaps, and for this runway, the runway 14 in Zurich International Airport, we have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the temperature of the air, and other data. The runway size, dry wet is going to give us the takeoff speed, V1, V rotate, and V2. We're going to use 140 knots, 250 kilometers an hour for takeoff with full thrust takeoff power like 99 or 100%. Also we're going to use 9 degrees of pitch attitude of rotation, 9 degrees, I'm gonna use the scissors, other instrument departure, weapons and figures, and crew horizontal vertical navigation figures, and I'll get honestly constraints. We're gonna climb to cruise level like 25, 26, 27, 29, 29, 30,000 feet above the sea level. I'm gonna cross through some waypoints and then descend, make a right turn, then descend back to the elevation of the airport like 76,000 feet above the sea level. We're gonna align with the magnetic north pole heading of the runway for approach and landing with the stars, with the star terminal arrival waypoints and fixes, and also with the Lszh localizer that I told you. We're gonna use the flaps to the 530 degrees. The land gear extended on airspeed of about 160, 170 knots, like 270 kilometers an hour, and it's altitude 9 degrees or less. So we're gonna using the Lszh localizer, the instrument landing system of the airport. And we're gonna be having a complete flight plan. So I'm gonna show you now how to use the flight management computer. So you can see here we have the keyboard, also the display, and the mouse pad I'm using to input all the data. So we use the index here to create identity, position, performance, takeoff, approach, and unfield status. So we're going over here. We have a few more minutes for setting up this for takeoff. So we have the control quadrant over here. So you can see this side display. So we're gonna use identity here, Boeing 787, Iraq cycle, the engines, position, Lszh airport, aligned the IRS. Also, the index performance, 0 fuel weight plus fuel on board, the gross weight for takeoff, cruising altitude, cost index, center of gravity. Also gonna use the departure and arrival over here, Lszh, origin, very fast, and destination, very fast, Lszh, runway 14. We're gonna use departures over here, so we set departures. We can select either runway 10, 14, 16, 28, 32, so we use runway 14, and the seats, the southern instrument departures, do it to alpha. So we have now the arrivals for approach, VOM 16, 2834 over here, LS 14, LS 16, ILS 2834, GLS localizers 34, localizers 38. So we use ILS 14 and Negria 1 Alpha and Transamiki. So we have the route is created but not yet activated because it's displayed with blue. We need to cancel the discontinuity here, over here, discontinuity. So we have to activate the reserve fuel, takeoff, gross weight, and the cruising altitude 25,300, the cost index 100%. So it's gonna give us the takeoff speed. We're gonna press execute, and we have the flight plan activated. Legs one by one. So I'm not having time this time to explain everything. We're gonna just set flaps for takeoff and center of gravity over here, trim, and the takeoff speed. So we have a few more functions: alternate, VNAV, progress, hold. We can hold, we can use fix and navigation, radio over here. So we go back in the virtual cockpit very quickly. We need to activate here the APU to start make an engine start demonstration. So the APU on, the start, primary flight control computers in the auto, air data computer here, flight control services, primary, the battery over here, down power, FD door, also window heat, rammer, passenger oxygen here, rammer turbine, hydraulics, left and right engine, primary demand, turn off. You will see the faults displayed over here, then turn on back and the auto position. So we have also wing and engine the eyes over here, on and auto. Also we have over here the recorders. We have the cargo and APU fire, the electronic engine control for the engines with the auto start mode over here in the start position. Start the engines, fuel jettison, get down some fuel, make an emergency landing, select the nozzles and how much remain, left and right wing fuel tank, fuel booster pumps, the crossfeed valve is on, you can feed either engine or balance the fuel between the left and right engine. So we have also the cabin pressurization here. In the manual, we use the outflow valves to pressurize the cabin of the aircraft as climate descent. Also, we have pressurizer from the packs from the left and right engine, hydraulic fluid tanks, and other system. So I'm gonna show you now the last thing before making the engine start demonstration here. The displays of all the systems. So you see over here we have the hydraulics IPUs running, the oxygen liquid cooling. So we have also the electric left and right IDZ 130 to 200 volts 400 Hz frequency, 130,000 kilovolts. The APU is running, the load cell and the batteries, main battery and APU battery over here. You see on the overhead panel. So we have the hydraulics here, where the hydraulic fluid goes. Also primary demand, electric C1 and C2, 5100 psi in the quantity of hydraulic fluid. Fuel on board the aircraft, we have left and right wing fuel tanks, center tank 11,000, 11,000, 11,000 total 33,700. High pressure fuel valves left and right engine, both feed the engines from the center. All the left and right wing APUs fed from left wing using the DC motor. The cross feed valve is off, but we turn it on. You can feed either engine with either pump or either tank. Also the minimum fuel temperature down here, so we recirculate the fuel from the tanks into the engines automatically to heat it up. Because it will freeze at minus 37 degrees in Pfizer. Right now it's minus 6. Also we do the same for the lubricant and the oil pressurizer from the packs from the engines for oxygen and other systems, cabin pressurization, the cabin, the gear, the pressure of the tires and the temperature of the brakes, flight controls over here. So you can see the movement of the flight controls like this in the display. Before we go for flight, you see all flight controls are moving accordingly. You see the displacement and also the horizontal trim stabilizer. FS display over here, maintenance over here, systems and circuit breakers. So we have the checklist, last thing to do before takeoff, after takeoff, the checklist and the communication. Navigation display back on. So we need to turn off both engines and restart them very quickly. So we turn off both engines controllers like this. You see fuel control off, fuel starvation will be displayed over here. So we have the engines off. So you see there is no fuel right now to the engines are going off. We need to restart them very quickly. We have not much time. Engine auto start very quickly like this in the on position. So you see the auto start is kicking in. We have N2 increasing. We have pressurizer from the APU right now. So only pressurizer, we need to start the fuel flow. So we let the fuel control on, fuel valves on, and we have the auto start is kicking in. So it will take like 1 minute, we're gonna have the engines ready for takeoff. So we have 33, 35, keeps increasing, you see all systems are running. Keeps building up. So we're gonna be having running engines in 1 second. Both engines with green running. So we set flaps for takeoff over here. Speed brakes up, increase the thrust levers and going for takeoff. We didn't set the autopilot, but we don't having too much time right now. For that we're gonna do that after flight, after takeoff. So we align with the runway heading over here with the center line. So we push the thrust levers all the way up after aligning with the runway, and we going for takeoff, align with the tiller over here, as you can see, and the rudder pedals. So we have until 100 knots. We push the yoke down, so we have 100, we have 120, V1, we rotate over here with 9 degrees, or less. And we have the takeoff, is a little bit more flat. So we have the takeoff, positive rate of climb over here. Landing gear up over here, as you can see, keep climbing. So you can see all the air data we have right now. You can see we are 1,100 feet above the ground, 300 feet above the ground, but 2,900, 3,000 above the sea. The airspeed 212 knots. Right now we are 2,000 feet above the ground. The radio altitude versus the barometric, so you can see we are 4,000 above the sea. We keep climbing with 5,000 feet per minute. The wind direction and speed over here. The stall speed you'll see later, the pitch attitude of the aircraft, also the engine's indication, and also the terrain below you here as displayed. You can see we are like 2,000 or 3,000 feet above the ground, and you can see the terrain, this red green indication in the vertical display, also the horizontal over here around you. You can see also the stall speed here, the stall speed with yellow and red. We need to avoid the stall, and also we can look a little bit further where we will see more terrain with red, green, rubber, and also the flight plan we need to follow. So we're going back outside. So we need to start the turn now. We have the runways here, which is for takeoff, and the lakes, the Switzerland. So we make the turn now. Very easy turn. We can leave the hands off, no problem. For an aircraft, we make turns without using a flight control in your hands, or you can keep it stable in flight. It's the only flight instrument can do that. So we need to be aligned here. As you can see, the flight data of the aircraft, gear data, and the navigation data, the waypoints we have to cross, also some other ground speed here, track, next waypoint, the airspeed here, the engine's indication, autopilot over here, not yet set. You can set the LNAV over here. So we'll look outside over here. We see a beautiful view of the aircraft, of the Boeing 787. We're gonna make a small flight, so you'll see a complete flight over here as we're gonna make it. You see this beautiful galactic view of the aircraft of the Boeing 787 over here. So we see the lakes here behind us of the Switzerland, also the Swiss Alps, the Germany, my homeland, in front of you. So we're gonna be making some small turn here as climbing. So we need maybe less flaps to increase the airspeed. As climbing, more airspeed is a good thing to have. So you can see the cockpit here after takeoff. Whole cockpit of the aircraft, the Boeing 787. So hope you like it. So we're gonna be making one more turn here to align with the LNAV navigation. You will see we need to align with the LNAV over here. Also look outside one more time, as you can see. So we're gonna be making a turn now in a couple of minutes, a few seconds. So we have the France here, the galaxy, my homeland Germany in front of you, the lakes of the Switzerland, Bayern Munich over here, Germany, and the lakes and the Swiss Alps. So keep climbing, and we're gonna make the turn now. See the lakes, and we can start turning. We use a little bit right rudder over here for the turn, as you can see. So we have the lake here. How do you do? Good. And now the Switzerland, very beautiful view.
You know how to do it?
So you can see the lakes here, the Germany and the Swiss Alps, and we make the turn here. We have the Bayern Munich, the France, and we're going back in the airport. So we align with the flight plan again, and a little bit right rudder for the turn. Hope you like. We see full manual flight, and we need like 8 more minutes to go back to the airport for landing. So we are 22,150 feet, and I'm flying with almost 900 kilometers an hour in a couple of minutes. When we're having the chemtrails, you can see the Boeing 787 900 over here. We align with the flight plan, all navigation instruments and displays, the autopilot here, and the head-up display. So we have the chemtrails now. So here is the chemtrails overflying the Switzerland, the Germany behind us, 23,000 feet or 7,000 meters with the Boeing 787, and the France in this side, the galaxy, very beautiful night view. So I hope you like the galactic view and the lakes.
Let me go check, okay?
So we need to cross through some more waypoints. Also the moon sign here, the crescent. We need to start now the descent of the aircraft, so we'll use flaps up over here and start the descent. Idle thrust also, and speed brakes. So we are going to be accelerating now for the descent. You can see the airport flashing runways over here. You can see also in the navigation display over here we have the airport as displayed. so we need to follow over here the flight plan for navigation. And we have 5 more minutes for descent and approach. Use full thrust over here, full airspeed. So you can see this shows you where we're gonna be descending using this current altitude and descent rate right now. So we need 10,000 feet. We need to be right here. I'm gonna be having this airspeed. We're gonna increase the rate of descent. I'm gonna be going faster, higher airspeed also. We can use. So you see the runway here behind us. Also the head-up display as we descend. Idle thrust, and we have a beautiful view from the cockpit again as we are descending now of the Boeing 787. Keep descending. So we have 4 more minutes to go for landing. We need to initiate the turn now, as you can see, crossing the waypoints here. So we make the turn very fast. Keep descending also, and use a little bit left rudder actually, not right. So we increase the rate of turn over here as we descend. Make more steep turn. And we need 3 more minutes to reach the runway over here. So you see we make the turn over here. A little bit faster in the turn. We need to reach the runway faster. We only have 3 more minutes for record this flight, so we don't need to lose the record time. So you see we keep flying over here, following the flight instruments on the line with the runway over here. Also we need to increase the altitude, increase the airspeed a little bit. Align with the runway. I'm gonna be aligned in a couple of minutes. You can see landing gear down.
Sorry.
And also the flaps are down over here. So we're gonna be having this nicer view from the outside for the landing. So we have some side wing and some wind gust for the approach. So we need to combat the side wing with the flight controls, the rudder pedals, the rudder and the ailerons and the spoilers. And we have 1 more minute for the video to end. So we have also the islet localizer over here for approach and landing. Need to align with the ILS localizer. So combat the side wind gust over here. a little bit more idle thrust, and we are almost ready for the flare. So you're gonna see the flare align with the runway, and flaring the aircraft here. So we have the flare, very beautiful flare and touchdown, very professional. Parking brakes and idle thrust reverser over here, full thrust reverse in line with the rudder pedals. So we're slowing down right now, as you can see. All landing gear is safe, there is no breakage. You can see the thrust reverse here. So we use idle for the thrust reverse. The thrust reverser retract. So we have the aircraft landed safely.